Welcome to Aaron the Teacher YouTube channel, where physics is made precise and concise to learn. I ask you of just one thing: please subscribe, like, comment and share to know where you watched from and what you have learned in this video. Let's get into our learning for today. May God bless you and give you understanding to live wisely. In Jesus' name, amen. Shalom. Once again, I welcome you all. Thanks for watching Aaron the Teacher YouTube channel. Today we are again going to have our learning, and we are going to look at a scenario concerning a convex lens. And the sample scenario before us is reading: your brother is a cameraman in the nearby town. The lens in his camera broke and he wants to replace it with an identical one. The lens he requires must have a focal length between 9 cm to 11 cm if the camera is to work properly. The supplier claims that the lenses he has have focal length within this range. You've been provided with the sample of the lens presented to your brother, and the task is asking us to help the brother to verify what the supplier says and advise him on whether to buy it or not. Of course, as a physicist, you are going to carry out a scientific investigation about this, and the problem at hand is us determining whether the focal length is within this range, meaning we are going to carry out an experiment to obtain that focal length. And the stages of our practical, as we all know, it begins with the aim until when you reach the conclusion. So our aim in this experiment, we are going to say an experiment to determine the focal length of the lens provided, so as to determine if it can be bought to be replaced in the camera, if the camera is to work very properly. Yeah, we've connected our problem with the purpose as to why we are carrying out the experiment, and the purpose is the focal length. Then the problem is whether to replace it in the camera or not. We shall go on to the hypothesis, which we are saying the hypothesis of the lens is between 9 to 11 centimeters if it is to be replaced in the camera for it to work properly. Hypothesis, it is always just a prediction. It may be a single value, it may be a range of values, or it may be a statement which we are going to prove it to be true or it to be a false statement or a value. And our hypothesis in this case, it is 9 to 11. And then we shall have the variables. Under the variables, of course, we begin with the independent variable, which I'm saying the object distance, and I've assigned a letter, or what I can say, a symbol, to show the object distance. My symbol, I'm using X. Then the dependent variable, it will be the image distance, for which in this case I'm using a Y. Now in the normal cases, we always have U and V, but not to promote cram work, let's change in and see whether someone is understanding or is just cram work. And those are points that an examiner can easily get to know malpractice. If at all you've been talking about UV and somewhere you misfire and put in XY, you interchange the symbols, you are easy to catch, meaning caution should be put on which symbols are using to represent your variables. Under fixed, or another person call it controlled, they're having light intensity and then the thickness of the lens, followed by the list of materials, where I'm having the lens holder, the widescreen, meter roll, the light source. And then we shall move on, of course, to now to the experiment setup, as it is there very well drawn with all the apparatus well shown. Please don't hide your things, and let not the examiner be be in anxiety to know what you're meaning. Draw things which are clear enough, well labeled, and well drawn diagrams. Very neat. Use a pencil or a pen, and then it should be working. It should be a working diagram. Yeah. Okay, then we shall not stay on that. We shall go on now to the steps which we are going to follow to carry out our experiment. The first step, of course, it will be our apparatus arranged as shown above. As you've seen it, that is how you're going to set them in the practical. Moving on to the distance, x between the object and the lens was measured beginning with x equals to 20.0 centimeters. I've begun with this, and I'm going to go on increasing in a particular range. Yeah, choose your values which are easy to find the range. Don't choose values which are hard to find their range. And in the same case, these practicals, by the way, they can be interchanged. I can begin from small to high, meaning I can carry out my practical with values in ascending order, or I can carry it out with values in descending order. The order depends on you. It is you to come up with it. So for instance, in this experiment, I began with a 20, and I'll go on 20 to 30, as you shall see other procedures down there. But the query is, where am I stopping? And I will say we shall be taking 6 values for physics subject, or for physics investigations. We shall be considering 60 values that you obtain, whereby the first one, which you began with as our x equals to 20, is the first, meaning we are going to add on more 5 to make the 6. I will not say on that. Let's look at procedure C. Procedure C is saying that the screen was moved towards and away from the lens until a sharp image of the light was formed on on it. Yeah, you move the screen towards and away until you find a sharp image. How does the sharp image form? Please, you are going to see which sharp image are we meaning when it comes to this procedure. Procedure D, the distance y from the lens to the screen was measured and recorded, and of course procedures B to D were repeated for more values of x equals to 30, 40, 50, 60, and 70 centimeters. You see where I'm stopping? I'm stopping at 70. Meaning if someone begins at 20, you will stop at 70. If you begin at 10, you stop at 60. Another person may begin at 30, you will stop at 80. So you interchange. Meanwhile, I can choose to change my order, and I say let me carry out the experiment in a descending value, which means that if I begin in a descending value, I'll begin at a high. For instance, if I choose to begin at 70, I'll come on 70, 60, 50, 40, 30, up to 20, the last value. And that's how the practical will be. So it is not cram work. It is understanding how is it going to flow. Procedure F, we're having the results were tabulated in a suitable table including values of x, y, that is a product, and x plus y, that is also a sum. And my sum, I put it in brackets, reason being it is a formula. The only case when my symbols are placed in brackets is when they become a formula. But it shouldn't be like a symbol also being put in a bracket. I've seen some people, they put, for instance, my image distance y, they put it in brackets, and also they add another bracket for the SI units. Please, that is very wrong. The variable which we are saying the symbol y should be outside, unless if it is functioning in a formula, as we can look at this one here. That's when you can only come to a bracket. And please, if it is a formula, never forget brackets, because it means a lot. It means a lot. If you leave the brackets out, I will consider that my y is the only one that you're going to be working with, is the only variable you're considering under that summation of x plus y. So the bracket changes meaning so much. We shall go to procedure G. And graph of xy against x plus y was plotted and its slope s was determined, as we shall look at graph work. And then lastly, procedure H, the focal length of the lens was determined from f equals to s. F equals to s, it is more of a theory work from the lens formula, 1 over f equals to 1 over u plus 1 over v, for which in this case I will consider it to be 1 over f equals to 1 over x plus 1 over y. How does it come to be f equals to s? Just leave a comment in the comment section. We shall have a video concerning some of those formulas, how they come to give us the graphs and how they come to connect to the slope and the practical at large. Please, I encourage you to continue watching. We are still moving on. We are now going to carry out our practical until when we shall reach the conclusion. Please like, comment, share, and subscribe to the channel, and God will bless you so abundantly. Okay, let's continue, please. Now this is the setup. Likewise, the source of light is here. I'm having my screen. I'm having my lens. Check very well. For this one, the lens is between the screen and the source of light, so don't confuse it with the concave mirror. And now we are going to do. Now I'm going to begin with a distance of 20. Distance of 20 between the lens and the mirror. As we can look through, it is at 20. So I'm going to move. Now that is the x, 20 centimeters. I'm going to move the screen, which is at this point. I bring it until a sharp image is focused on the screen. And you take it at this, and this is the sharp image I'm focusing. You can look through. That one is fading. When I go beyond, that one is also fading. So the sharp image is between that, the point when it just forms. I note that. And now I measure the distance between the lens. Measure the distance between the lens and the screen. The distance will be between from 20 up to 39.2. Up to 39.2. So I'm just going to get 39.2 minus 20. Of course, that will be. If I press 39.2 minus 20, that's 19.2. Then I go again and measure the distance. When this time it is at at 30. At 30, the distance between this. Can look through, it is at 30, and up to here it is at 0. Then I come again and move my screen until a sharp image is focused, and I will take it to be that. If I move beyond, it is fading. If I move behind, it is also fading. So it is just at some point like that. And I still come and measure the distance from here. Here it is at 44.7. So I get 44.7 minus. Sorry, I get 44.7 minus 30, giving us 14.7. That is at 30. Then at 40, I come and measure the distance between this. At 40, I move the screen until a sharp image is formed, and that is it is at 53.8. So you get 53.8 minus 40, giving us 13.8. I record it somewhere, 13.8. Then I'm running with at 50. I move it in the distance. Then I still move my screen, and this time it is at that point. It is at that point there. I again come and record. So this time it is at 62.5 minus 50. That will give us 12.5 at 60. Our second last at 60 distance. I move it. It is giving us at that point the distance between the lens and the screen. It will be at 72.2 minus 60. 72.2 minus 60, giving us 12.2. 12.2. And then the last one, which is at when the distance is at 70. I move my screen till a sharp image is formed, and my sharp image is formed at that point. It is formed at that point. Again, come and measure. Come and measure. This time it is is at 82 exactly. So I get 82 minus 70. Minus 70, giving us 12. So we shall record it. But I guess we are having it at 81. 81.8. 81.8. So we shall get 81.8 minus 70, giving us 11.8. 11.8. And those are our values that we are going to use to plot a graph, x and y, where x is the object distance and then y is the image distance. So let's move on to another step. Now here we are having our table. It is consisting of 4 columns, and the first column, it is consisting of the distance x, which we said it was the object distance, and the distance y, which was the image distance. And then we shall add on another column of x times y, which is the product, and another column of x plus y, which is the sum. Now in the column of x plus y, I'm having centimeter squared because I'm multiplying centimeter of x and centimeter of y, which is giving us centimeter squared, meaning I have to always add it there. Don't make a mistake of writing just centimeters because it was a product. Then when it came to the sum, you're having x plus y. Now I'm putting this in brackets. Still, I will emphasize here to make it one concrete value. If you leave it outside, it will perhaps show that our centimeters, or which the units, are only acting on y, and therefore you may end up losing a mark there because you cannot add x and y, then you get different units. So it is in a bracket to make it a formula
which is giving us a single unit. Now we are moving on to generate our column, which is x times y, and it is a product. And the first row, which I'm having 20 times 19.2. If I multiply it through here, you get 20 times 19.2, giving us 384. Now let me first record this aside, and then I'm going to guide. We are going to use, we use the biggest product. If I multiply 20 times 19.2, it is giving me 384. Then how about this one? Let's test and we see. 70 times 11.8, I'm getting 826. 826. Now, between this and this one is bigger than this. Not so. And you realize we've been multiplying 3 significant figures against 3, meaning our answer should also be to 3 significant figures. And as we can see, it is giving us 826, meaning it is not having a decimal point, and therefore it is going to dictate it is going to dictate the decimal points for the rest of the column products. For instance, if I write this one will be 826, the next one, of course, the first one we said it is 384, which I will put here. And then the second one will be 30 times 14.7, which I'm getting 441. And then next one, 40 times 13.8, which I'm getting 552. Then I'm having 50 times 12.5, which I'm getting 625. And the last is 60 times 12.2, which I'm getting 732. Of course, the product of 70 times 11.8, we already obtained it from here. And now that will be our column. Next, we shall have on the column, which is this. We are going to add 20 plus 19.2. If I say 20 plus 19.2, I'm getting 39.2. Now this column, what is going to dictate is the number of decimal points on each of them. I'm having, this is 1 decimal point plus 1 decimal point, giving us 1 decimal point. So all the values here are going to have to 1 decimal point. If I add 30 plus 14.7, I'm getting 44.7. This is 44.7. Of course, this one will be 50, 0.8. This one will be 62.5. Then 60 plus 12.2, giving us 72.2. And then lastly 70 plus this, which is 81.8. And those are the values we are going to use in our plotting. Now moving on to the plotting. Now we are continuing to first get our scale for each of them. We are going to plot a graph of x times y against x plus y. How does this come about? We come from the length formula, 1 over f equals to x plus 1 over y. If I get the LCM here, I'll get 1 over f equals to xy divided by x plus y. And of course, this divided by this, I get y. Then plus this divided by this, I get x. So I've just interchanged them to maintain the coherence there, but it doesn't affect anything. Now from this, of course, I'm looking to making f the subject. I cross multiply f into x plus y equals to x y times 1. If I divide through by x plus y, I get f equals to x over y divided by x plus y. And therefore it tells me that I'm going to plot a graph of x times y divided by or against x plus y. In the end of the day, that change in x over y divided by change in x plus y will give us the gradient. And therefore, we shall equate our gradient to s. Meaning, if we get the gradient s, it will be equivalent to f, which is the focal length. And that's the theory of the practical. Now, let's get into getting our scale. I begin with the horizontal scale, of course. Horizontal scale. I'm going to get a value. Horizontal scale, I'm getting 81.8 minus 39.2. I get 81.8 minus 31.2. I'm getting 42. So I get, 81.8 minus 39.2 divided by, on the horizontal we divide by 8 big squares. So this answer, I divide it by 8, and the answer I'm getting 5.325. Now, which scale are we going to take? Realize these ones are less than a 5. I guess we can take a scale of 5 basing on our 1, 2, 5 scales. This value is lying between, if I take to multiples, I get 10, 20, and then up to 50. Now this value is lying between 5 to 10. It is lying between this range. Now what am I going to get? I will take a 10 to represent my scale on the horizontal, meaning my horizontal scale will be equals to 10, whereby one small square will be equivalent to 10 divided by 10, giving us 1. Okay, and then how about vertical scale? It will be my highest value, which is 826 minus 384. Then I divide by 10. I'm getting 44. Okay, let me write what I'm saying. I'm saying 826 minus 084 divided by 10. On the vertical, we divide by 10 big squares. Please note the difference. Now, we've said I'm getting 44.2. I still write I'm getting 2. My standard scale, getting this 20 and 50. Now, we realize 44.2 is lying between 20 and 50. But it is more nearer to 50. Therefore, I will be taking a 50 as my scale. And hence, my vertical scale is equals to 50. So coming back to my, of course, one small square will be equivalent to 50 times 10, giving us a 5. I come now to the graph. Begin demarcating. I can begin from here. I can choose from this. Of course, you first gaze it through. If your scale is 10, on the vertical, if your scale is 50, you first gaze through and you see. If I begin at this value and I add on plus 50, I'll get 50, 100, 150, 200, 250, 300, 350, 400, and 86. But you realize my beginning value now has to change. It has to change. In that, In this column, my lowest value is 384. So I choose a value which is less than this. And then that value is the one that I'm going to add on the scale. So 384, if I choose a value, say 350, that is the one I'm going to begin with. Let's see. If I begin at 350, I add on 50, I get 400. 450, 500, 550, 600, 600, 650, 700, 750, 800, and then 850, and then 900. So you realize 850 is here, and 850 is more than 826, whereas 350 is less than this, meaning I can choose to take that as my scale. And of course, let me first mark on, and I begin at this point. My lines will run up to, the lines should finish up to up, like that, and then I clearly indicate this arrow. The arrow shouldn't pass, the arrow shouldn't be halfway, it should be exactly at that value, at that point. Then also here, I will take it to be like this, and I will, likewise, I also make the arrow like this. As I said, I'm going to begin at 350. When I add on, I'll get 400, 450, and then 500, and then 550, and 600, 650, 700, 750, then 800, and 850, then lastly 900. You can choose to stop at that. Of course, I shouldn't forget labeling my axis. This is a graph of x, y, which is in squared against x plus y into this. And of course, a graph of what? Of x, y against x plus y. Still, I re-echo, don't bring units in the title. Just write the symbols only, as you can look at it as I've written it there. Don't mix concepts. The units, we shall bring them while writing, labeling the axes like this. But if it is the title, that is how it should be. Of course, I'm done with that. Then I also come and demarcate my horizontal. After every 10 small squares. Never forget doing this. This is demarcating. And also here. To this. Like that. Now that is the whole of our graph, as we can look at how it is flowing. Of course, we are left with this one. We said on the horizontal, we are going to take a scale of 10 and still come and look through. I'm having 39.2. This value, I'm going to come at this value and check, or I choose a value which is less than this. It is up to you to choose. It is up to you to choose which value you're going to take. But I will choose a value, for instance, 35. Meaning I write 35 as my starting value. 35 plus 10, I'll get 45. 45 plus 10, I'll get 50. 5 plus 10, I'll get 65, 75, and then 80, 5, then 90, 5. Yeah, that is 10, 10, 10, 10. And my highest value will be within this column like this. And that will be my demarcation of the graph. The next thing we are left with is just to plot. Plotting, still I will advise or encourage us to always convert these values you are going to plot into small squares. For instance, I will come on the vertical axis, I'm having x, y. I'm converting these values into small squares, likewise to these ones, so that it becomes easy for me to plot them. And how do I plot a point? How to plot a point? We always say that for me to plot a point, I get the value to be plotted, minus the starting value. Then the whole of this divided by what one small square represents. And that is how we are going to move. Of course, every value to be plotted will differ depending on the starting value. So for instance, on the vertical, I'm going to begin with the vertical values. I'm going to get 384 minus the starting value on the vertical. We said it is 350. So minus 350 divided by what one small square represents on the vertical. We said one small square represents on the vertical, one small square represents 5. Are we together? One small square represents 5. So I get divided by 5. Now this figure computed, I will get 384 minus 350. The whole of this divided by 5. I'm going to plot 6.8, which I approximate to 7 small squares. I convert these, and meaning I'm going to plot 7 small squares. Mind you, the whole of this is your side work, please. The whole of this is your side work, but it is so helpful as we can see. Then I'm having 39. Now that is plotting 384. Let me plot plotting 39.2. I'll get the same value, 39.2, minus my starting value on the horizontal, which was 35, minus 35 divided by what one small square represents on the horizontal. We said one small square represents 1. So it will be divided by 1. And when I substitute 39.2 minus 35, of course divided by 1, giving us 4.2. So I'm having 4.2, but I approximate them. Since this one is less than 5, I will plot 4 small squares. Meaning, I'm going to plot x plus y as 4 small squares. Please, you do the same for all of that, and you realize that I'm going to get, for the next one, it will be 4, 4, 350, then divide by 5. I'm getting 18.2, which I'll round off to get 18 small squares. Let me first work for the first column. I go 552 minus 350 divided by 5. I'm getting 40 small squares. Of course, I've rounded off to 40. Then 624 minus 350 divided by 5. I'm getting 55 small squares. 732 minus 350 divided by 5, getting 76 small squares. And then lastly, 826 minus 350 divided by 5, which I'm getting 95 small squares. I do the same for this one. I come and say 44.7 minus 35. Now this one I'm going to round off 9.7 to give us 10, meaning I will plot 10 small squares. The next one we are having you're having 53.8 minus 35 divided by minus 35 divided by 1. It is giving us 18.8. I round off to 19 small squares. And I'm having 62.5 minus 35, giving us 27.5. Now that one, that 0.5, we maintain it, meaning we shall estimate a half of a small square, and that is the 0.5 we shall plot. That one we don't round it off. 72.2 minus 35, giving us 37. I round off to 37 small squares. Lastly, 81.8 minus 35, giving us 46.8, which I round off to 47. Now I've converted the whole of these values into small squares, meaning when I'm counting or when I'm plotting, I'm just going to be counting small squares for each of them. Can we begin? And I hope we are good to go. Let's begin with, of course, plotting. I plot horizontal against vertical. Horizontal against vertical. This was horizontal, this is the vertical. So let me begin. I'm going to count 4 small squares from here. I always count from the start. All together. So I'm counting 4 small squares, which are here. Then against what? Against 7. So I count upwards against 7, and my 7 is here. Are we there? So I make a dot, then a small circle. Your circle should be within that square which is there. It shouldn't exceed outside. Then the next one, I'm going to plot 10 against 18. I will count from here to here. They are 10 against 18. This is 10 against 18, it is here. So to be at this point, these are 18. From here to here, they are 10. So I plot this one will be this, then my value. And the next one I'm plotting 19 against 40. I come and count, these are 10 plus 9, which is here, against 40. I count, this is 10, 20, 30, 40. I move upwards, and it will be at this point. I also make the point like that. Please, are you following? If you are following, just leave a thumbs up, I mean a like, and also comment in the comment section. Then we move on to 27.5. Now 27.5, I count. These are 10, 20, and then I count 7. 7 is here, then 0.5. I estimate the half of this next square, and I count, it is against 55. I count, these are 10, 20, 30, 40, 50, up to 55, which is at this. So I estimate upwards, I can use a ruler, estimate upwards like this, 10, 20, 30, 40, 50, up to this point. And at this point is where I will estimate that point like that. Then I'm plotting 37 against 76. These are 10, 20, 30, and then I count 37, which is here. That's 7 against 76. So 10, 20, 30, 40, 50, 60, 70. 76. This is 70. I add on 6, which is here. That is the point. And then lastly, I'm having 47 against 95. I count 10, 20, 30, 40, 7. Do you see here? Against 95. 10, 20, 30, 40, 50, 60, 70, 80, 90. 90 what? 95 to be this line. So I come and locate upwards up to this point. Up to this point. Now that is my graph, as we can look at the points 1, 2, 3, 4, 5, 6. The next thing, of course, it is drawing the line of best fit and coming up with the coordinates, which are going to help us to obtain the slope. Let's move on to this line of best fit. Now, line of best fit, I always emphasize that you make sure that most of your lines appear on the graph, on the line. Most of your points appear on the line. But if they fail, then always make sure that at least most of them will touch and leaving equal number of points either side. If I pass through this point and this point, you realize it is passing through this, or it is touching this, it is touching this, and it is leaving 1, 2. Yes? Or let me add just maybe. If I make it to go through this, it is going to touch this, and it is going to pass through this, leaving this one and this one, this other side, then leaving this one and this one, this other side. So this one, it will be a fair graph if I make it to go through these 2 points. Let me make it like this. And that is my line of best fit. It is passing through this point and passing through this point. Meanwhile, touching this one, but leaving, this one is moved the other side, and also this one is moved the other side. This one is moved this side, and this one is moved this side, meaning it has balance. Of course, the next thing is to also draw the triangle. A triangle, we said we look for the first point where this line is crossing in. And if I'm to check, you realize it is passing through this, this one, we shall leave it. It is passing through this one here, this point here, is where it is going to pass. Now you make sure that all your values, these plotted points, are within the triangle. Meaning you choose a point outside this one, or which is beyond this last one, and also choose a point which is lower than this first one, for you to be able to draw your triangle. So for mine, I've chosen this. Please comment if it is coming out. Leave a like, a thumbs up for what you are doing. Then also, I also come and select this one. I realize that it's passing through this one. Meaning my triangle, I'm going to draw like this. Now for these 2 lines meeting here, these ones, they should always be bold lines. Then for these other ones proceeding on to the axis, they can be dotted. These other ones, they can be dotted like that. And then also up here, we dot it up to the y-axis. And I'm ending up forming a coordinate, this coordinate. I'm ending up forming this coordinate like this. So I'm having this and this. Those are the 2 values which are going to help us to form the slope. Of course, this is a right angle triangle, so I indicate it. Friends, there we are. Now coming up with these 2 values, this is very simple as long as you are following your scale. It's very simple. I'm going to say, let me first begin with reading this one. This one, for me to read it, I come and look at the value which is before all of these small squares, and the value I'm getting, it is a 75. Then I say plus into brackets. How many small squares are from this point to that point? There are 9 of them. Into 9, but times what one small square represents on the horizontal. We said on the horizontal one small square is representing 1. Therefore, if I compute this, I'll be getting 75 plus into brackets 9 times 1, which is 84. And also, still, I also come and read this value up here. This value I'm still going to say the value before it, which is 850, plus into brackets. How many are they? They are 2 small squares times what one small square represents on the vertical. We said one small square represents 5. Represents 5. So I'm going to say times 5, giving us, if I multiply this, I'll get 850 plus into brackets 2 times 5, giving us 860. So these are the 2 values which are going to come here. Of course, we write in XY form, meaning it will be 84 again and 860. Still, coming back to this, the same thing, the value which is before it is a 35. The value which is before it is a 35 plus, how many small squares are there from here to there? There are 4. Times what one small square represents. This will be 35 plus 4, giving us 39. And likewise, I also get from here, the value before it is 350. Then I say plus, how many small squares are there? There are 5. So plus 5 times what one small square represents, we said times 5 on the vertical, giving us 350. 350 plus into brackets 5 times 5, which is 375. So when I'm writing here, I'm going to write and say 39 and the 375. Guys, that's our graph work. What we are remaining with is just obtaining the slope, writing down the errors and the mitigations, and then the conclusion, and that will be the end of our practical. Stay firm, follow along as we go on and we proceed. Don't forget to like, comment, share, and subscribe, and the Lord will bless you in Jesus' name.
So we are going on to calculate our slope, and the slope we are going to calculate from changing x, y, divided by changing x plus y. In other words, our product divided by the change in our sum. And substituting on the our values that we obtained from the graph, we have 860 minus 375, then divided by 840, divided by 84 minus 39. In the numerator we shall get 485 and then divided by 45. Then our units, of course we are maintaining them. The numerator we have in centimeters squared divided by centimeter. When we press in the calculator, we shall have 10.8 centimeters as the slope, and we relate back to our relationship between the slope and the value that we are looking for, which is focal length. After relating, we said f equals to s. It means that f will be directly equals to 10.8 centimeters. Sources of errors and mitigations. The first error we are having is spherical aberration, which can be mitigated by using a lens with a small aperture. If the lens is having a very large aperture, it can cause an error in the values. Then the next error is zero and scale. errors, which can be mitigated by using meter rule with a fine end and a consistent scale. These arise from using a meter rule with a beginning value or beginning point when it is damaged, when it has faded. So you find a difficulty in allocating the zero mark. So you have to use a meter rule with a fine end and also a consistent scale, a scale which is at least in a standard among the standard scales. Another error, difficulty in identifying the sharpest image, which can be mitigated by slowly adjusting the screen position to find the sharpest focus of the image. That is also always that is also always a source of error, because someone may be confused to take a faded image, yet it is not all that sharp. Another person may take a blurred image, but yet it is not yet sharp. So it must be very sharp to get the actual results. Another error is what you are calling the inaccurate object or image distance placement, which can be mitigated by accurately measuring and the double checking of the object and image positioning. When you place your image, which is when you place object, which is a source of light, the bulb, double check again. Don't assume with the first placement. And also double check again when the image is formed, is it the actual position that you are measuring, before you read them off. And then after that, that is how the sources of errors were and how we could mitigate them. These are not the only ones, there are as many as possible, but we've managed to write this. Then another stage is now the conclusion. Now the conclusion, you're concluding in line with the hypothesis, and we are saying the hypothesis is accepted since the focal length f is equals to 10.8 centimeters, and this lies within the given range of 9 centimeters to 11 centimeters. Hence, it can be replaced in the camera for it to work properly. Our conclusion, we connect the hypothesis either by approving it or disapproving it. And then after approving the hypothesis, we now connect back to the aim as to why we're carrying out the experiment. And our purpose was to help the brother if the camera is to work very properly. And after you've done that, that is the end of the practical. So never forget to connect the purpose to the hypothesis by accepting or rejecting it, or we can say by a hypothesis is true or it is false. So it is just about vocabulary, but that is the concept behind. Guys, thanks very much for watching. May God bless you. Don't forget to like, comment and subscribe, and share this video to help someone. I love you all in Jesus' name. Shalom.